application of the law of sines bearing. We're talking about navigation problems here. The bearing of an object refers to the direction that it's traveling. We're going to measure that bearing in degrees using clockwise from due north. And I've got a little picture here. When we talk about bearing, we're talking clockwise from north. And right away you can see that's kind of annoying because that's not the normal way that we measure angles, right? We usually start at the positive x-axis and usually go around counterclockwise for positive angles. Here we're measuring clockwise from north, so you got to keep that in mind. Let's take a look at our example problem. We've got an airplane, leaves the airport with an initial bearing of 65 degrees. It travels 35 miles, then it turns and it heads due south. South would be down. And then finally it goes back to the airport with this final bearing of 320. And what we want to do is find the total distance. How far did this plane travel in all? Well, a good picture is very, very critical. I'm going to go ahead and start my journey here at 0, 0. So this will be the airport. There's no reason to pick anything more complicated. So we'll start here at 0, 0. And first, the plane travels with a bearing of 65 degrees. That means measured clockwise from north. So that would be roughly about here. We're saying this angle, clockwise from north, is 65 degrees. And the plane goes along like that for 35 miles. So we know that distance. And then after that, it turns and it starts traveling due south. So that would be straight down. I'm not exactly sure how far it goes here. We're going to have to figure that out. And its final bearing back to the airport is 320 degrees. So it's going to go back to 0, 0. Now what I find helpful when you have to change directions and it's not just, up, down, left, or right. When you change directions, I find it helpful to draw myself a tiny little axis here at that spot, because then I can easily mark on my bearing. Remember, bearing is from north going around clockwise. 320, let's see, that's almost to 360. So that would be something like this. It would be almost all the way around, just 40 degrees short of 360. And so my final bearing back to the airport looks like that. That red angle that we drew there is the 320. 320 degrees bearing measured clockwise from north. Okay, so I think we've got a pretty good picture now. What do we want to find? Oh, we want to find the total distance. Well, that would be the 35 miles. We know that. I don't know this distance. I'm going to have to figure that out. And I don't know this distance. I'm going to have to figure that out. If I can figure out those other two distances, I can add them all up and I'll have my answer. Well, obviously we've made here a triangle, so we're immediately thinking, oh, what rules do we have? I don't see any right angles, so this is an oblique triangle, which means the law of sines is going to be our tool here. Now, looking at this triangle, I don't have very many pieces filled in. I mean, I do have some angles written down, but they're not in the triangle. And so I'm going to have to use a little bit of geometry here in order to fill out some angles. The first angle that I can fill out is this guy right here. I can do that because in geometry, this line here, the due south line, and the y-axis, those are parallel lines. When you cross two parallel lines with a transversal, it's called, from geometry, the alternate interior angles are identical. In other words, here's two lines, parallel lines, cross them with another line, well, this angle and this angle match. And that's what I have in this picture here. So therefore, this angle is also 65 degrees. So I do know one of the angles of the triangle, 65. And let's see. Oh, I think I know the one at the bottom too, because if that red angle is 320 from the axis here all the way to this spot, remember we said we stopped 40 degrees short of a full rotation, so that means this angle is 40 degrees. So I used a little bit of the picture, a little bit of geometry, and now I think I have enough pieces to find what I need. I have two of the angles, I have one of the sides. How about I call the other sides that I don't know B and C? Do I have a complete pair? Yeah, I have. That would make this A, I guess. I have A is 35 and I have alpha is 40. So I have a complete pairing. To find side B, I guess I'll need to know angle beta. Angle beta is this entire angle here, and I can easily get that because the other two angles are 65 and 40. 65 plus 40 is 105. I know that all three angles are going to add up to 180, so that leaves me with 75 for angle beta. So beta is 75 degrees. And now I can use the law of sines. I'll use this first one here, the one connecting the alpha A relationship and the beta B relationship. So I have sine 40 degrees, that's my alpha, over the opposite side, 35, equals sine 75 degrees, the beta angle, over B. B is what I don't know. I can quickly now cross multiply, do my math, and I'll have angle B. I get B sine 40 equals 35 sine 75, and divide both sides by that sine 40, and we've got it. Here we cancel. I can go to the calculator now. Let's see, I'm in degree mode. 35 sine 75 divided by sine 40, and so we've got a distance of, I'm going to keep it a little long right now so I don't round until the end. How about 52.595? And then we'll just do something similar to find side C. Let's see, once again, I'll start with the alpha A pairing. It's always best to use the pairing with the exact values if you can. The other one is a rounded value, so I'm connecting alpha A to gamma C. Angle gamma, let's see, that's opposite C. That would be the 65 degrees. So sine 65 over C. Again, I can cross multiply and divide. C sine 40 equals 35 sine 65. Divide, go to the calculator. Let's see, 35 sine 65 over sine 40 looks like 49.349. Let's see, do these answers make sense? Alpha is the smallest angle, and A is the smallest side at 35. Next would be 65 degrees across from the 49. Yes, that's the medium side, and then biggest angle is 75 across from the biggest side. So all of this makes sense. All I have to do now to get the answer is add up A, B, and C. So I've got the 52 answer plus the 49 answer plus 35. And we wanted to round to one decimal place, so it looks like 136.9. And so the total distance traveled by the plane is 136.9 miles. You can see where the quality of the picture is everything in these problems. Thanks for watching.